My dear friends and followers, today I want to talk to you about recycling, specifically plastic recycling. And allow me to share my screen. There we are. Just a minute to start this presentation. Um, I want to start with these slides, and this comes from the Ellen MacArthur Foundation, because the question has been raised if recycling is part of the circular economy. As you can see very clearly by this graphic, the Ellen MacArthur Foundation consider here in the external graphic, consider recycle as part. You see, this is the external link, they are internal link, but very clearly the concept of circular economy have two areas, no? The areas of stock material to the right and renewable flow and management to the left. And the center is, of course, the materials, finite materials, or materials coming from fossil. They go through this process. First, they become parts, then they become products, then they become service, and in the end, of course, they come to either consumers and user and become waste. And what you do with this waste. One important point in the concept is to keep those materials in the loop. This is what recycling does. Recycling, of course, is not the only. You see, there are many others circles here. If you can reuse the material, of course, you should do that. When you can substitute the material for material which are less impacted, has less impacted in the carbon footprint, you should do that. But also to keep the materials in the loop, in the production for longer is a very important part in the circular economy. There is no doubt about that. Now, if you look at the situation of plastics, this is what this graphic, and this graphic is from 2016. It's outdated, I would say, but the situation has not changed. And what you see there is really less than 1% from at that time, 300 today is more like 360 million tons. So the amount of plastics waste has increased considerably. And the recycling situation has not improved very much. Chemical recycling is still a very small fraction, may have changed for 1 to 2, 3%, something like that. Mechanical recycling, you see here in the top, is around 12% at the best. No, but the majority of the plastics, 40% goes still, and this has not changed, to landfills. Go to landfills, and what is even worse is this area here down, which is unmanagement dumps. So a lot of plastic go directly to the nature, and this, of course, causes a huge problem. 25% of the plastic, especially in the more advanced countries, now industrialized countries, they go to incineration. Incineration solve the plastic problem, of course, and produce heat, but it is, of course, coupled to CO2 emissions, which you want to avoid. What I always say when we speak about plastics, it's very important that we consider the chemical structure of plastics. And here you see some example. Look in the top row. These are the olefinic plastics, no PA and PP, and those plastics are composed only of carbon and hydrogen. Long chain of carbon and hydrogen. So much so that we consider plastics as solid organic carriers of hydrogen. Inciting this innovative and disruptive because it solves the problem of plastic waste. When you start looking at the plastic waste as carriers of renewable carbon and renewable hydrogen, you have already solved the plastic problem. So the road to plastics, to the solution of the plastic problem passes into this new insight of what plastics really are. I have spoke about this before. I would say, of course, there are different things you can do with plastics at the end of their life. If the plastics are biodegradable, and there are only a tiny fraction of plastics are really biodegradable, you can compost the plastics. But many people believes that bioplastics are biocompostable. This is not the case. Bioplastics have an origin in the biomass, but their chemical structure is exactly the same as fossil. So they are not compostable. All of those plastics, they have limitations in their possibility of recycling. Reuse is very limited. Most of the plastics, they are not produced to be reused. They are really produced to be single use. And mechanical recycling works, but has several limitations. And 2-3 times, then you have phase separation, you have downgrade. Chemical recycling is an option that has not been used very much. It's only, as I said in the first graph, 1%. And it is so because people have really not paid attention to that. But if you pay attention to the chemical structure of the plastics, then it's very simple to come with a recycling solution. The drawbacks of mechanical recycling, I will not go. It is really 2 to 3 times recycling cycle because you have plasma degradation. That's the reason you cannot do it this way. I spoke that several times. Today I will not speak. I just say that there are three thermal process for taking care of plastics, and the difference of these process are in the what they do in the products. Now it depends of the product. If you want to heat, now if you want really the heat for boiling and then producing power, you should choose incineration of the plastics. It works. The only problem with incineration, you have emission. Now those two processes, pyrolysis and gasifications, they are without emissions, but they are for different process. It depends of what you want to do. If you really want to go for chemistry, and I think this is the crown of the recycling, keep the materials at the same level of quality, then the approach of choice is gasification. And we have developed this technology of low temperature gasification, which I will speak. Now, if you go to the classification of chemical recycling, you see those products, precipitation, depolymerization, solvolysis, pyrolysis, and gasification. And the particle size is going down here. Now, the particle that you need, so for gasification, you need very small particles to be able to gasify. But what is the product of gasification? Carbon monoxide and hydrogen, only that. And that is the beauty, because carbon and hydrogen is what all the organic chemistry is based. And in principle, you can use this technology. I will not go into the detail here, but this is a comparison between these technologies. I will post this presentation so you will be able to look into that. But here I compare, I benchmark the different technologies so that you can go for the detail. Very important here to say is that gasification is the only one that you have yes, yes, yes for all the types of plastics. It's very flexible, and that's the reason we choose a gasification. What we do, well, consumers, they produce plastics. We take the plastics and shred the plastics to very small size, and then we gasify in our own equipment. And from that, the product is only two gases, nothing else: carbon monoxide and hydrogen. And those gases, they are commodity for the chemical industry. So the chemical industry already uses those gases to produce all of the chemistry, and not I say, of course, you have the possibility of burning the gas as a fuel and for thermal gas, but this is not what we do. We do exclusive gas for chemistry, and that is recycling, close the loop recycling, plastics to plastics, and open loop recycling, plastics to valuable chemicals. That is what we do. And I will not today go through this, but I will just say that gasification is a fine dance between the production of carbon, hydrogen, and oxygen. So we have to control very well the parameters in order that we have as a product only carbon monoxide and hydrogen. We have no CO and no char. I will jump, but this is, I spoke, when we gasify plastics, we produce syngas. And this is a graphic that shows the flexibility of syngas. Out of syngas, you can start by doing methanol or just separating the gas, and then you have a very easy way to produce hydrogen, what we call white hydrogen, hydrogen from waste. So you can produce hydrogen from waste, but you can also use the syngas for producing all of the chemistry. Everything you can produce out of syngas. That is the beauty. That is the flexibility of this approach. So this is real life. This is our equipment as we have built and validate. And this is what we do. So I thank you for having listened to that. Thank you so much.